Welcome to cryptography session. Today I am going to give an explanation for a monoalphabetic cipher. There are two types of traditional techniques are available. One is substitution and another one is transposition. The third technique is steganography. So these three techniques are come under a stream cipher technique. In a stream cipher technique, every letter is replaced with some other letter. Either the letters are replaced or its portions will be replaced. So, character by character of replacement or character by character representations of encryption is called as stream cipher. And another type is block cipher, in which a collection of characters will be treated as a single block. So, the block size will be varied depending upon the size of the block, and the number of letters will be taken as one block and will do the encryption operations. Then stream cipher techniques. First technique is a substitution, which contains two subdivisions in it. One is monoalphabetic cipher and another one is polyalphabet cipher. Monoalphabet cipher contains two algorithms, CCS cipher and affine cipher. Polyalphabet cipher contains four different algorithms, namely Cipher, Vignier, Hill cipher, Vernam cipher. So substitution means replacement of one letter with another letter, or we can be able to replace it as number or symbol. So every plain text letter is replaced as letter or a number. If the plain text is a sequence of bits, ciphertext also should be written in a bit pattern. So the number of plain text and number of ciphertext should be equal if you use a substitution technique. Transposition means only the position of the plain text letters are differed. So permutation of plain text letters are possible. So the same letters are available in both plain text and ciphertext. Steganography is one of the cryptographic mechanism in which a plain text contains a hidden message in it. So if you see the message is like an original message, but it will contains some hidden informations in it. So existence of message is also possible under steganography. The best example for steganography is the watermarking technique in digital image processing notation. So in a substitution technique, the first technique is mono alphabet. So mono means one. So it is mono. So for every letter we should replace another letter. So totally 26 keys are available from A to Z. We represent the numbers from 0 to 25. So I will tell later about why we put 0 to 25 for A to Z. The first technique is cipher technique, in which the letter is taken as only one letter is taken as key. So if you want to apply a mono alphabet cipher, the length of key should be 1. So if you take K as key, so we should take only one length key for implementing mono alphabetic cipher. So that key value may be a letter, a single letter, or its corresponding number. Then that number is represented from A to Z. Here total numbers are available. So I only take the number from 0 to 25. And we will do only simple addition and subtraction operation here. So if you add two values, there may be the possibility of getting greater than 26 value. For that only we should use mod operation. So that only the number is represented from 0 to 25 instead of 1 to 26. Because if you do modulus operation, the remainder for 26 is from 0 to 25. So the numbers are represented from 0 to 25. So for encryption, we should take every letter of plain text. Its corresponding number should be added with the number of key letter. So a letter which is represented in a number format, that is also available in key. We should add it. If that value is greater than 26, we should do modulus operation. So if encryption contains plus, we should do subtraction. So addition is done at encryption, we should do subtraction at decryption. So this is the generalized formula. So here C is a ciphertext. So ciphertext is done for encryption. So encryption of plain text with key, the formula is P plus K mod 26. For getting decryption, ciphertext value is subtracted by a K. K means key value, that is also mod 26. For example, I am taking the plain text value as Happy Onam. So, if a plain text contains any blank spaces, blank space means either space or a tab symbol or a blank symbol, so or a new line. So, this will be treated as white spaces. So, if a plain text contains white spaces, we should ignore it and we should take the continuous letters as a single plain text. And here the key is given, so key is 3, the number 3. Then we should check the value. So the encryption is P plus K mod 26. So corresponding H value is 7, A means O, P means 15, Y means 24, again O 14, N 13, A 0, M 12. So these numbers will be retrieved from the given table. So the table contains the alphabet symbol and its corresponding number format. Then you simply add 7 plus 3, number is 10. So the 10th letter is K. 0 plus 3, third. So the third letter is D. 15 plus 3, 18. 18th letter is S. If you take 24, 24 plus 3 is 27. 27 is greater than 26. So if you do 27 mod 26, you get the remainder as 1. So the one number represent B. So in this way, we can able to write the answer. So here the values are 10, 13, 8, 18, 18, 1, 17, 16, 3, 15. And we can able to retrieve the plain text from the ciphertext by subtracting K value. So here 10 minus 3, 7, 7th value is there, 3 minus 3, it's available. For example, if you take 1, 1 means 1 minus 3, it is only minus 2. But negative number is not represented in a table. So what we should be do means, you should add 26 with it. So if you add 26, we can able to get the positive value, that means 24. So the 24th letter is Y. So in this way we can able to get it. So if K is used in encryption, minus K is used at decryption. So minus K is an additive inverse of K. So what is additive inverse means, if you add K and its additive inverse, the number should be 0. So totally 26 values are available from 0 to 25. So it is Z26. So what are the additive pairs means, if you add 0 with 0, you can get 0. So 0th additive inverse is 0. If you add 1 and 25, you get 26. 26 mod 26 is 0. So for 1, it is 25. For 2, additive inverse is 24. 3 means 23. If it is 4, its corresponding additive inverse is 22. 5, 21, 6, 20, 7, 19, 8, 18, 9, 17, 10, 16, 11, 15, 12, 14. For 13, the same number is an additive inverse. And for 14, 12 is there, it is already available as a pair, so it is not repeated. So totally 14 additive inverses are available in Z26. So if you get the number 3, so 3's corresponding value is 23. So in this way, you can substitute it here. So instead of minus 3, I can able to substitute 23. So the number is 1. 1 plus 23 is 24. So either you just do subtraction operation. If you get the answer as negative value, you should add 26. Then you can able to get a positive value. Otherwise, we are already write the additive inverse pairs. From that one, you get its additive inverse. So for number 3, the additive inverse is 23. You just do only the basic addition operation in decryption also. So minus k, instead of minus k, you can able to do plus k representation. Here minus k represents its additive inverse. So in this way, the CCS cipher technique will be used. But the disadvantage of this technique is encryption and decryptions are done. So totally 26 keys are used. So instead of a single letter, we can able to write it in 26 ways, 25 ways. Apart from one letter, we can able to write in 25 ways. So it is easily predictable, which means that brute force attack is easily possible in a CCS cipher method. And the second technique is affine cipher. So in a CCS cipher also we can do multiplication operation. So encryption means we can do multiplication operation. P into K mod 26. If you want to do decryption, P is equal to C divided by K mod 26. And this will be written as C into K inverse mod 26. So if a number is A by B, which may be written as A into B inverse. So these two values are equal. So instead of division, I can able to write it as K inverse. So here K inverse is a multiplicative inverse of K. So if you take Z26, multiplicative inverse means if you multiply K and its inverse, the number should be 1. For Z26, if you multiply K into K inverse and if you do mod 26, the answer should be 1. So if you take Z26, the numbers are from 0 to 25. If you multiply 0 with any number, you can't able to get the remainder 1. So 0 has no multiplicative inverse. If you take 1, 1 into 1, 1 mod 26, 1. So 1 multiplicative inverse is same 1. For even number, there is no possibility of getting the remainder 1 in Z26. So there is no multiplicative inverse for even values. And for 3 nines are 27. So 27 mod 26 is 1. Like that, we should be able to find out the multiplicative inverse list in Z26. So we can able to use it. For example, if you take the same notations, here I am writing the value. And its number. So totally 26 values are available. So I am taking happy as a plain text and only one value should be taken as key. So I am taking the same key value as 3. So H value 7, A value 0, P value 15, another P value 15, Y value 24. K is given as 3. So ciphertext is 7 into 3, 21. So 21th value is V. 0 into 3, 0. So the value is A. 15 into 3, 45. 45 mod 26. So it means 19. So the 19th letter is T. So the answer is T for the consecutive 2 letters. 24 into 3. So 48 plus 24, it is 72. So if you take 26, 26, 26, 52. So if you subtract it, the answer is 20. So the 20th letter is U. So this is for C. So you write its corresponding number. V is 21, it is 0. For T, it is 19. If it is U, the answer is 20. And the same K value. So here we should use K inverse. So 3th corresponding K inverse value is 9. So you should multiply these numbers with 9. You can able to get the value. So 21 into 9, it is 189. So if you do modulus operation 52, 52, 104, 104, 52, 156, 156 plus 26, it is 182. So the remainder is 7. So the 7th value is H. 0 into 9, 0. So 0th value is A. So like that we can able to easily retrieve the answers. So in CCS cipher, either if you do encryption with the plus, we should do the subtraction operation. In encryption, multiplication is available. We should use its multiplicative inverse. So this is the main logic behind CCS cipher. The affine cipher technique will be discussed in next session. Thank you.